Hello, good evening, everyone. How are you? I hope you everybody are fine. Today we are going to develop the concept regarding alkyl group, functional group, homologous series, and alcohol and its type. These topics we are going to touch and understand about it. Let us start our topic, alkyl group. To understand the alkyl group, first we need to have knowledge about alkane, and I hope you have seen my previous video. There we have talked about the alkane and its structure. Let us draw some alkane over here. This is one alkane, and I hope you know its name also. Here is one carbon, so its root word will be meth, and all single covalent bond, so its suffix will be ane. So its name is methane. Let us see one more alkane here. This is the another alkane, and its name, it has a two carbon, so its root word will be eth, and all single covalent bonds, so suffix will be ane, so its name is ethane. When one hydrogen is minus from alkane, then alkyl group is formed. From any of the alkane, if any one hydrogen is removed, that becomes the alkyl group. Okay, what I want to say here, let us take here one example. When any of the hydrogen, suppose I removed this hydrogen from this alkane, from methane, then it becomes alkyl group. For example, if I removed this hydrogen, actually how hydrogen is connected here? It is connected by the single covalent bond. One electron is shared by carbon, another electron by hydrogen, and by sharing of one electron, this bond has been formed. And when hydrogen is removed, hydrogen will go by taking its electron, and one electron of this carbon will be left over with the carbon here. This becomes the alkyl group. Then what is the name of this alkyl group? We can see from here. Alkane, one hydrogen removed, it becomes alkyl. From alkane, A and E, one hydrogen is removed, then we have to remove A and E and put there YL. See the name. A and E is removed, and in this alkane, A and E is removed and YL is added over there. So its name will be the alkyl group that is formed from this methane. This alkyl name will be A and E will be removed and YL will be kept over here. This name will be YL, methyl group. Okay, I hope you are understanding this. This is alkyl group, but what is the name of this alkyl group? This is made from methane, so its name is methyl group. Okay, similarly, this is ethane. When any hydrogen is removed, suppose this hydrogen is removed, -1H is becoming here, then this compound, this becomes now alkyl group. When one hydrogen is removed, then this becomes alkyl group. Then what will be its name? Which alkyl group? It is formed from ethane, then A and U will be removed, YL will be kept over in this name. So its name will be ethyl group. Okay, this is methyl group, this is ethyl group. These are the example of alkyl group. I hope you are understanding this. If there is any problem, please comment. This alkyl group can be defined as when one hydrogen is removed from the alkane, the group whatever is forming, that group is called alkyl group. And this is a highly reactive group because the carbon has one valence free electron here. This electron wants to uh, get shared with any other group here, because here the octet of carbon is not completed, because here 2 electron, 2 electron, 2 electron, 6 electron and 7 electrons are only present around the carbon. This carbon wants to share this electron, this electron. This alkyl group is highly reactive group. Okay, this alkyl group can also be represented like this. Uh, suppose we are suppose we are representing the alkane like this, R dash H. Then when one H is minus from this alkane, then whatever is remaining here R not. This can be R not, or R simply R and one symbol of electron over here. This can be the symbol for alkyl group. Okay, I hope you are understanding this. In this way also we can represent the alkyl group. Now we are going to develop the concept of functional group. Let us see what is functional group. Functional group. Suppose this is any alkyl group and this carbon wants any group to come and react over here. Suppose at this point any OH group came and attached here, then this compound will become alcohol. Okay, if at the place of OH CHO group came and attached here, then this compound will be aldehyde. If here COOH group came and attached here, now this group will be called carboxylic acid. Carboxylic acid. What I wanted to say here, that if OH is attached to the alkyl group, that compound becomes alcohol. If CHO is being attached, that compound is becoming aldehyde. If COOH is coming and attaching here, this compound is becoming carboxylic acid. If Cl, F or I is attaching over here, then that compound, this compound becomes haloalkane. What I wanted to say here, this atom or group of atom, when they are attached to the alkyl group, they are determining the nature of this compound. Either they are alcohol or carboxylic acid or aldehyde or haloalkane. This alkyl group is not determining, but this group, this OH, CHO, COOH, the ClF. This atom or group of atom is determining the nature of compound when they are attached to the alkyl group. Then this atom or group of atom, they are called functional group. I hope you are understanding. This atom or group of atom, when they are attached to the alkyl group, they are determining the nature of this compound. They are acid or alcohol or what. That is determined, this atom, that is determined, this its nature is determined by these atom or group of atom. Then these small atoms or group of atoms, these are called functional group. I hope you understood what is functional group. Okay, if still there is any problem, you can comment. Okay, now we are going to develop the concept of homologous series. Homologous series. Suppose any compound is here, its structural formula is like this, or its another molecule is here like this. Here, let us first, before studying this, let us know what is a structural formula, what is condensed formula, what is molecular formula. This, we are representing the compound by showing all its bond. This is called a structural formula. This is a structural formula. Okay. When we are representing this compound like this, suppose this carbon has 3 hydrogen, so we can write CH3. This carbon has 3 hydrogen, CH3. This compound can also be written like this, CH3, CH3. If we are representing like this, then this becomes condensed formula. This is called condensed formula. If we are representing like this, carbon how many? 1, 2. Hydrogen how many? 6 total. If we are representing like this, C2H6 to this compound, then we are saying this is molecular formula. This is molecular formula. Okay. I hope you understood this. Now again we are going to the concept of homologous series. After this, I am drawing this alkane. This is also alkane. One more carbon is here. Another carbon. Another alkane I am drawing here. One with one more carbon than this. That here is 2 carbon. I am drawing here 3 carbon alkane. Then its condensed formula can be written like this. Suppose its condensed formula will be CH4. Its condensed formula is CH3, CH3. Its condensed formula will be CH3, CH2 and CH3. When we draw one more alkane with one more carbon than this, that will have condensed formula like this, CH3, CH2, CH2, CH3. Because we can see here this this compound and this compound we are comparing, then this compound, this down one compound is more by CH2 group than this. CH4 is here and CH3 is here. Then one C and 2 H. Here C has total hydrogen 4 here, hydrogen 6. So 2 hydrogen is more and 1 carbon is more. When we compare this and this compound is more by CH2 group than this. Similarly, this down one compound, this is more by CH2 group than this. Then when we are writing this all compounds like this, CH4, CH3, 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 CH2, CH3, now this CH3, CH2, CH2, CH3. If we are writing like this, then this series which differ from each other by CH2 group, this series is called homologous series. This is called homologous series. A series of compound that differ from each other by CH2 group, this series of compound is called homologous series. Okay, and we can say this is the alkane, this is also alkane, this is also alkane, and this is also alkane. So we can say this is the homologous series of alkane. We can also say like this. This is the homologous series of alkane. Okay. Now let us see some other example of homologous series. Suppose this is alkyl group, this is also alkyl group, this is also alkyl. And at this place, suppose OH came in attached here. This is OH came in attached here, OH came in attached here. Then how this compound will be written? It will be written like this: CH3OH. This will be written CH3, CH2 and O. Yes, CH3, CH2 and this OH. This will be written CH3, this CH2 and here also CH2 and here OH. When we see this structure, this compound and this compound we are comparing, this is more by CH2 group, this is more by CH2 group than this. Then and every compound contains OH, it means this all compound is alcohol. Okay, and these compounds are differing from each other by CH2 group, then this we can call this is the alcohol series. They contain similar functional group and they differ from each other by CH2 group. Each consecutive terms is more by CH2 group. From this to this is more by CH2. From this to this is more by CH2. Then and all are containing this OH. It means all are alcohol. Then we call it, this is the homologous series of alcohol. So we define the homologous series like this. We can define a series of compound, they differ from each other by CH2 group and they contain the same functional group. Then that series of compound is known as homologous series. Okay, I hope you understood this. If still there is any problem, you can comment. Now we go to the our last topic, that is alcohol and its type. Okay, we have seen the structure of alcohol just now. From any alkane, suppose this is any alkane and from this alkane one hydrogen is removed, and at the place where hydrogen is removed, suppose at that place one OH group is added, then we find this structure. Suppose this hydrogen is removed and this OH is added over here, then this becomes sorry, this becomes alcohol. When one hydrogen is removed, it becomes alkyl group, and at that place if OH group is added, then it becomes alcohol. Okay, this is the uh, from we can say like this is the alkane, and from alkane one hydrogen is minus and one OH plus is added, then it becomes alcohol. Okay, then how the name of alcohol is written, let us try to know. This alkane is here methane, it is, this is methane. Then when alcohol is formed here, the name of alcohol is written like this: alkanol. Alkanol. From alkane, E is removed and OL is E is removed and OL is added over there, then this becomes the name of that alcohol. Suppose this is methane, then from this methane that last E will be removed and OL will be added here. It means from methane the alcohol that is formed, its name will be methane. E is removed, OL is kept here. Its name becomes methanol. Okay, this is the alcohol. Alcohol is a group, and inside that alcohol lot of different types of alcohol are there, and one example is methanol. Okay, similarly, suppose here is like this, suppose ethane is there, two carbon alkane is called, this is called ethane. Okay, and from ethane if one hydrogen is removed and one OH is added over there, then what is formed here? Suppose this hydrogen is removed and OH is kept there, then what is the name of this alcohol? Let us try to know. Uh, in this ethane, name E is removed and OL is kept here. It means its name will be ethane. E is removed, OL is kept here. This is the structure of ethanol. I hope you are understanding this. This is the structure of ethanol. And this ethanol, this alcohol, people use for drinking. This alcohol is used in different types of medicine. This alcohol is used in sanitizer and different purposes. This alcohol has wide range of use in our daily life. Okay, in this way alcohol are formed. Okay, there are three types of alcohol. Let us see. When we are talking the basic concept of alcohol, basic type of alcohol, the alcohol is of three types. That is monohydric alcohol, monohydric alcohol, dihydric alcohol, Okay, and trihydric alcohol. Okay, let us see example. What is monohydric alcohol? Suppose any alcohol is formed like this. They have only one OH group, or any alcohol like this, two carbon alcohol. When you observe this compound, in this whole compound, only one OH group is present. In this whole compound, only one OH group is present. When the alcohol contains only one OH group, then that type of alcohol is called monohydric alcohol. And we know how to write the name of this alcohol. This is methanol, this is ethanol. Methanol, ethanol. Okay. Let us see the example of dihydric alcohol. If there are different number of carbon, okay, in the alcohol, and at two carbon there are OH group. Let us see nicely. Suppose there are three carbons, and at any two carbons there are OH group, then this alcohol is called dihydric alcohol. Two OH group, two hydroxyl group is present in the alcohol, then that alcohol is called dihydric alcohol. This is example of dihydric alcohol. Similarly,